Good afternoon. Good afternoon. Today we will start gear strength of gear tooth. This is the last expression. After this, we are going to solve problems. Now, wear strength of gear tooth. Now, first of all, I will discuss what is by wear. Wear means what? Removal of material. Wear means what? Removal of material. Therefore, in case of gear, wear means removal of material from the surface of the teeth. Therefore, when wear will be there, that surface hardness or hardness of gear tooth will come into picture. Therefore, hardness of the gear tooth must be sufficiently large so that it can transmit the power without wear failure. We have seen different types of wear: abrasive wear, scoring wear, initial pitting, destructive pitting. All these wears, types of wear phenomenon we have seen. Therefore, when the contact stresses between two meshing teeth exceed the surface endurance strength of the material, then wear will take place. Pitting is a surface fatigue failure characterized by small pits on the surface of the gear tooth. In order to avoid this type of failure, the proportions of the gear tooth and surface properties, such as surface hardness, should be selected in such a way that the wear strength of the gear tooth is more than the effective load between the meshing teeth. The analysis of wear strength was done by Earl Buckingham in his paper The Relation of Load to Wear of Gear Teeth, which was submitted before the American Gear Manufacturing Association, that is AGMA, in 1926. Buckingham's equation gives the wear strength of the gear tooth. Therefore, Buckingham's equation is based on Hertz's theory of contact stresses. When two cylinders are pressed together, as shown in figure A, the contact stress is given by sigma c is equal to 2p divided by pi into b into L, equation A, and b is equal to into bracket 2p into bracket 1 minus mu square into bracket 1 upon E1 plus 1 upon E2 divided by pi L into bracket 1 upon D1 plus 1 upon D2 bracket complete bracket raised to 1 by 2, where sigma c is equal to maximum value of the compressive stress in Newton per mm square, P is equal to force pressing the two cylinders together in Newton, D is equal to half width of deformation in mm, L is equal to axial length of the cylinder in mm, D1 and D2 is equal to diameters of the two cylinders in mm, E1, E2 is equal to modulus of elasticity of two cylinder materials in Newton per mm square, and mu is equal to Poisson's ratio. Now these two circles you are seeing having diameters D1 and D2. Therefore, in case of Buckingham equation, he has considered two gears as two cylinders. Now this is the front view of the two cylinders. This is the deformation length. When two cylinders are pressed or when two gears are pressed against each other, this total deformation is there at the point of contact, that is nothing but 2b. Therefore, in while calculating, we have taken b only, half width of deformation, and p is nothing but force pressing the two cylinders. Two cylinders means two gears to each other. Therefore, first of all, just to write down these two paragraphs, I will wait for 5 to 10 minutes. Again, you draw this figure, write down this. Again, I will wait 5 to 10 minutes. Therefore, please start writing. I think you have written. Next slide. Draw this diagram. Due to deformation under the action of load P, a rectangular surface of width 2b, consider this as the rectangular surface, and length L length is perpendicular to this slide, is formed between the two cylinders. The elliptical stress distribution across the width 2b is shown in figure B and C. This is the elliptical stress distribution. When these two cylinders will press against each other, this is the rectangular surface will be formed. This is rectangular surface. See that here. This is the elliptical stress distribution. Therefore, draw this diagram and write down fast. Substituting equation B in equation A and squaring both sides, we are getting sigma c square is equal to 1 divided by pi into bracket 1 minus mu square into p divided by l into bracket again 1 upon r1 plus 1 upon r2 divided by 1 upon e1 plus 1 upon e2, equation C, where r1 and r2 are the radii of the two cylinders. Substituting where R1 and R2 are the radii of the two cylinders and substituting mu is equal to 0.3. Mu means Poisson's ratio. Therefore, sigma c square is equal to 0.35 into P divided by L into 1 upon R1 plus 1 upon R2 divided by 1 upon E1 plus 1 upon E2. Therefore, write down this equation C and D. Make it fast. Next slide. The above equation of the contact stress is based on the following assumptions. The cylinders are made of isotropic materials. Isotropic means the property of the material remains same everywhere. Properties means physical properties. The elastic limit of the material is not exceeded. And third, the dimensions R1, R2 are very large when compared to the width 2b of the deformation. Therefore, write down these assumptions. Figure shows the contact between two meshing teeth at the pitch point. The radii R1 dash and R2 dash in equation D. Sorry, please replace these radius by R1 dash and R2 dash everywhere. Whatever we have seen in equation C, write down here R1 dash, R2 dash. Also in equation D, write down these radius as R1 dash and R2 dash. Only dash sign you put. Here also R1 dash and R2 dash. The radii R1 dash and R2 dash in equation D are to be replaced by the radii of curvature at the pitch point. Therefore, R1 dash is equal to dp sin alpha divided by 2 and R2 dash is equal to dg sin alpha divided by 2. Therefore, these equations came by considering sine cos tan relation, considering right angle triangle. For R1 dash, we have to consider this as the triangle. This radius is dp divided by 2. Therefore, sine alpha is equal to R1 dash divided by dp divided by 2. Therefore, R1 dash is equal to dp into sine alpha divided by 2. Similarly, considering this as the right angle triangle, we have considered sine alpha is equal to R2 dash divided by this dg divided by 2. dp divided by 2 is equal to pitch circle radius of pinion. dg divided by 2 is equal to pitch circle radius of gear. Therefore, draw this figure and write down these two formulas or two equations or two values, whatever it is. Write down, draw the figure also. For next, there are two reasons for taking the radii of curvature at the pitch point. The wear on the gear tooth generally occurs at or near the pitch line. When only one pair of teeth carries the entire load, the contact occurs at the pitch point. When the contact takes place at the top or at the bottom of the tooth profile, usually two pairs of meshing teeth share the load. The dynamic load is imposed on the gear tooth near the pitch line area. Therefore, it is more reasonable to select the radii of curvature at the pitch point. Therefore, what this paragraph says, general or major wear of the gear tooth occurs at or near the pitch point. This is the first point. And second, when only one pair of teeth carries the entire load, the contact occurs at the pitch point. And also, whatever the dynamic load we have seen, dynamic load due to manufacturing defect or surface inaccuracies or due to the number of teeth. This dynamic load is more in the area or in the region nearer to the pitch line or nearer to the pitch point. That's why we have considered radius of curvature at the pitch point. Therefore, 1 upon R1 dash plus 1 upon R2 dash is equal to 2 divided by sine alpha into bracket 1 upon dp plus 1 upon dg, equation E. We have to define ratio factor also. A ratio factor Q is defined as Q is equal to 2Zg divided by Zg plus Zp, where Zg is equal to number of teeth on gear, Zp is equal to number of teeth on pinion. Therefore, substituting dp is equal to m into Zp. Dp means pitch circle diameter of pinion and dg means pitch circle diameter of gear. Therefore, dg is equal to m into Zg in above equation. Therefore, Q ratio factor, we are getting it as 2dg divided by dg plus dp. Therefore, whatever this bracket is there, that will replace 1 upon dp plus 1 upon dg is equal to dp plus dg divided by dp into dg, which is equal to 2 divided by q into dp. We have substituted value in terms of q. That's how we have got this value. dp plus dg divided by dg is equal to 1 upon q, 1 upon 2q. That's why this value is there. Sorry, 2 divided by q. Therefore, 2 divided by q into dp, equation G. Therefore, write down these equations, make it fast. Okay, therefore next, from equations E and G, therefore 1 upon, consider it as R1 dash, 1 upon R1 dash plus 1 upon R2 dash is equal to 4 divided by Q dp sin alpha, equation H. The force acting along the pitch line is Pn means normal force. Therefore, P is equal to Pn, which is equal to Pt upon cos alpha. This equation we have seen in force analysis. Equation J. The axial length of gears is the phase width B. Therefore, L is equal to B. Equation K. Therefore, substituting equations H, J and K in equation D, we are getting sigma c square is equal to 1.4 pt divided by bq dp dash sin alpha cos alpha into bracket 1 upon e1 plus 1 upon e2, equation L. Therefore, write down these four equations. Consider here 1 upon r1 dash and 1 upon r2 dash. Therefore, a load stress factor K is defined as K is equal to sigma c square into sin alpha cos alpha into bracket 1 upon E1 plus 1 upon E2 divided by 1.4. Therefore, substituting the above equation in equation L, we are getting Pt, that is tangential force, is equal to BQ dPk, equation M. This equation gives a relationship between the tangential force Pt and the corresponding contact stress sigma c. Here it should be sigma c or K. When the tangential force is increased, the contact stress also increases. Pitting occurs when the contact stress reaches the magnitude of the surface endurance strength. The corresponding value of Pt is called wear strength. Therefore, write down these two equations and afterwards directly we will write down Pt is equal to SW. Therefore, write down first these two equations. Therefore, the wear strength is the maximum value of the tangential force that the tooth can transmit without pitting failure. Therefore, replacing Pt by Sw, equation M is written as Sw is equal to dq dpk, where Sw is equal to wear strength of gear tooth in Newton. Consider this as sigma c. Oh, sorry, SC only. SC is nothing but surface endurance strength of the material in Newton per mm square. Above equation is known as Buckingham's equation for wear. The ratio factor Q for internal gears is defined as Q is equal to 2Zg divided by Zg minus Zp. This is for internal gear. Whatever expression we have seen, it is for external gear. External gear means the gear which is having teeth externally. Therefore, write down this and we'll stop here. Enter your numbers.